Hello everyone, today in this video we'll be discussing the fifth module of data mining and data warehousing, which is regarding the clustering algorithms. Okay, so in the module 5 what we have is the clustering and the related concepts. The module is divided mainly into four parts. The first is the introduction to clustering, then we have three main clustering algorithms, then we have cluster evaluation, there's some methods are discussed, and then we have three other clustering algorithms. So this is what you need to know from this module. Okay, this is all what the whole module talks about. Okay, so the flow of this video will be as follows. We'll be going through each of these topic in depth and seeing what are the types of the questions that are asked and what you need to keep in mind. Okay, and we'll be discussing the important concepts as well. So before starting, if you like this video, hit the like button and don't forget to subscribe to my channel. Okay, so let's discuss the flow what are in these four topics. Let's start from the first topic, which is introduction to clustering. So let's discuss what all you need to know from these topics so that you can answer 80 to 90% of the questions from this module. Okay, the first one is the introduction to clustering. There we have some definitions. Okay, so from introduction to clustering you need to know these two things. Okay, define clustering and what are the different types of clustering. There are three types of clustering, which is hierarchical versus partitional, exclusive versus overlapping versus fuzzy, complete versus partial. Okay, so these are the different types of clusterings. Then we have what are the different types of clusters. So there are five types: well separated, center based, graph based, density based, and shared property based. So we'll be discussing each one by one. Okay, so that's all what is there in the introduction to clustering chapter. Then we have three main clustering algorithms, which is k-means, agglomerative, and DBSCAN. Most important topic means part of this module is this topic. Okay, means k-means algorithm is there and few more things which I'll be discussing, as well as numerical is there. Then we have agglomerative, and then we have DBSCAN. Okay, so let's see what is there in the three main clustering algorithms. K-means, agglomerative, and DBSCAN. See, in the clustering algorithms, whenever they ask you about the algorithm, for any algorithm you need to know the following: definition and its meaning, algorithm, key concepts and subcategory topics, graphs, formula or equation, problem type if applicable, and advantages and disadvantages. For each of these topics you need to know the following. So we'll be discussing in depth each of these one. Okay, so let's start for the K-means. I'll give you a brief overview of what all you need to keep in mind for K-means. Okay, so there is a definition for it and an algorithm associated with that. Then we have the key points. Okay, so in key points, what is this algorithm based on? The algorithm is based on these two things. Then we have two strategies to decrease SSE by increasing the clusters and decrease the number of clusters while trying to minimize SSE. So these are few concepts which they can ask in exam, so you have to explain these ones. Those come under the key points. Then we have the final key point, which is the bisecting K-means, and then we have strength and weakness and numerical associated with that. So these are the things which you need to know if you want to score full marks into the topic K-means. Okay, so the next one is the agglomerative and DBSCAN. Those are the shorter topics. Let's see what is there in that. In that we have the definition. In agglomerative hierarchical clustering, the main topic is hierarchical. Okay, hierarchical clustering is the main technique. It is divided into two parts: agglomerative, which is also known as merge; divisive, which is also known as split. See, at this point of time, even if you are not getting the flow of what I'm telling, still try to understand, because when we will be discussing the concept, then you will recall at the first part of the video I had told these things, right? So it will be easy for you to keep track of what is happening. Okay, so keep listening. Defining the proximity between the clusters, there are three things: min, max, and group average. All are very easy topics. I'll be discussing this in depth. Okay, that's what is there in the agglomerative and hierarchical clustering. Okay, along with that we have the algorithm and the strength and weakness as well. Then we have DBSCAN clustering. In that we have the definition, key points. Two key points are the center based approach. It is a center based approach. So what do you mean by center based approach? Along with the graph is there, and there are three classifications: corner, core, border, noise, or background points. Three types of points are there. Along with that, three diagrams are there which you need to know. Then we have the algorithm and strength and weakness. That's what it is there in the second chapter. In third chapter we have cluster evaluation. There are three methods of it: unsupervised, supervised, and relative, and they have the separate types of it as well. Okay, in the last chapter we have the other clustering algorithm. These are the new algorithms which have been added in the syllabus. In the previous schemes it was not there. Okay, so what we need to know from each of these, that I will be discussing. These are the subtopics which you need to know. Okay, so let's get started with the module. So the module 5 starts from page number 95 and it ends till 128. Okay, so we'll be going through briefly regarding the topics, and I'll be telling you what you need to keep in mind and focus more upon. Okay, so the first topic is about the clustering analysis. Okay, so what you need to know in that, if I open again what I had showed you, so I showed you this one. Introduction to clustering. Here we have define clustering and what are the different types of clustering. These are two questions which you need to know. What is clustering? Cluster analysis groups the data objects based on the information found in the data that describes the objects and the relationships. So based on the relationships and the properties, the clusters are made. For example, if you have two colors, green and blue, and the objects are of either green color or either of blue color. Okay, so you have to make two clusters. What you will do, you'll make a cluster here for red and you'll make a cluster here for green. What are the green objects, you'll keep it here. What are the blue objects, you'll keep it there. That's what clustering is. It will means analyze the property of the object and it will place it according to the cluster. Okay, and it can be based on the similarities as well as dissimilarities. Means dissimilarities means that dissimilar things will be placed in different clusters and the similar things will be placed in single cluster. So using both of these techniques we can classify the things. Okay, so that's what the clustering means. So you have to explain that when they ask you about the clustering. If you want, you can give an example as well. Then we have the different types of clustering. Okay, so various types of clustering are hierarchical versus partitional. A partitional clustering is simply a division of the set of data objects into non-overlapping subsets that each data object is in exactly one subset. So there is different subsets here, and those are means one point will be in a single subset, not in a multiple subset. That is the partitional. What about hierarchical? Hierarchical means it will be organized as a tree. Means there will be a root node here and it will be classified into two parts, then each of these will be classified into further parts. That's what the hierarchical clustering is. Okay, then we have the next classification, which is exclusive versus overlapping versus fuzzy. So I'll give you an example of what is exclusive. Exclusive means each one will be having a separate one, means a separate space it will be stored. It is same as the previous one we have discussed, partitioning. Okay, exclusive will be safe, means same. Overlapping means one of the data objects or more data objects will be in two classes. For example, if I take an example of a person at a university, they can be both enrolled as a student as well as an employee of the university. So that person belongs to the student cluster as well as the university cluster. That's what the overlapping is. Then fuzzy means fuzzy clustering, where every object belongs to the cluster with the membership weight that is between 0 and 1. So 0 means absolutely does not belong, 1 means absolutely belongs. So we'll take a new object and we'll see how much it belongs. Means if it is more closer to 1, we'll assign that value, means whatever the decimal value comes. If it is closer to, means it is not closer to something, we will be assigning it close to 0. Okay, that's what a fuzzy clustering is. Then we have the complete versus partial. In complete, we will consider all the points and place them in different clusters, whereas in partial we will just place means how many are required, and all, it's not necessary that we need to place all. So some points also might be left. That is known as partial. So till now what we have discussed what is clustering. Clustering means dividing the data set into different clusters and assigning each data point to the one of the clusters. That is known as clustering, based on the similarities as well as the dissimilarities. These are the 2 points, and the third point is you have to you means see the similarity between the objects, and those will be placed in the same cluster, and the difference means the because of the differences they will be placed in the different clusters. These are the 3 points you need to mention. Then we have different types of clustering: hierarchical versus partitional. What is hierarchical? Like a tree based the separation, that is hierarchical. Partitional means each data point will have a separate cluster. Exclusive versus overlapping versus fuzzy. Exclusive is just one data set will be in a one cluster, and overlapping means more than two clusters can be in the same one. Fuzzy means it will be assigned a value between 0 and 1. Complete versus partial. Complete means all the data points will be assigned a cluster. Partial means few data points could be left also. That's what it is there in the first part of the first chapter, which is introduction to clustering. Here we have discussed this. Let's move on to the next one, which is what are the different types of clusters. So there are 5 types of clusters. Let's have a look at those. So different types of clusters. Well separated cluster means the distance between the two clusters must be high. That is well separated cluster. Then we have prototype based on the center based cluster. In the center based cluster, there will be a center for each cluster, and wherever the object is closer to, it will belong to that cluster. Means, for example, if I take this point is closer to this center, so it will be in this cluster, belonging to this cluster. Then we have the next one, which is graph based cluster. In graph based cluster, there will be a connection or a link between the two graphs, and how it is arranged arranged and how it is means connected, in that we will be representing that. Means if it is represented like this as a graph, arrange values from this one to this one, you will be making a cluster in this form only. It's mainly based on the values of the graph. Okay, that is known as the graph based clustering. Then we have the density based clustering. It is based on the density. If it is more dense, it will be one cluster. If it is means less dense, it will be one cluster. Okay, so based on the density we'll be classifying the clusters. Then you have the last one, which is the shared property cluster. Here if the two clusters overlap, that is also considered as a cluster. Okay, so here is a dotted cluster, here is a line cluster, they both overlap at these points, so that is a shared property cluster. Okay, so that those were the 5 different types of clusters. So we are done with the chapter 1, introduction to clustering. We have 5 different clustering techniques we have discussed now. Okay, so let's move on to the next one. Next chapter is the 3 main clustering algorithms: k-means, agglomerative, and DBSCAN. So keep in mind we need to know these things. Revising again: definition and meaning, algorithm, key concepts and subcategory topics, graphs, formula and equation, problem type if applicable, advantages and disadvantages. Okay, so these are the things which you need to keep in mind for each of these algorithm. So let's get started with k-means algorithm. First we need to know the definition of it. So let's see what is the definition of k-means algorithm. In the k-means algorithm, it intends to partition the n objects into k clusters in which each object belongs to the cluster with the nearest mean. So there will be two values, for example like 5 and 6. If I take a number sorry, not 5 and 6, 2 and 12. Suppose it took two numbers, 2 and 12. Now I'll tell you a number 5. 5 is closer to 2 or 5 is closer to 12. Is 5 closer to 2 or 12? It is closer to 2, so it will be belonging to that cluster, 2's cluster. So like that we will take 2 points and then we'll be putting the objects in either of these two classes. Okay, that's what the k-means clustering is. What I talked about is 2 cluster. It can be 3 points also, it will be 3 cluster, 4 points 4 cluster, and so on. Okay, that's what k-means clustering is. So if they ask you the definition, what you have to write is k-means clustering intends to partition n objects into k clusters, 100 objects into 2 clusters in which each object belongs to the cluster with the nearest mean. Okay, so we'll see a numerical that will make things more clear for you. If you want more information that is given here, you can go through it. Okay, then we have the next topic, which is the algorithm. What is the algorithm of k-means clustering? Select k points as the initial centroids. As I told you, if I have 100 numbers, I'll take 2 points, like for example 30 and 70, that are the 2 k points. Then repeat. Why we are repeating? We are selecting 2 points, again assigning the numbers to those points, and after that again means selecting a mean of it. So what does mean give is another number it will give, and then again we'll compare all those numbers to the new mean. Okay, then we'll again assign the groups until the mean values does not change. So that will be more clear when I discuss the example. So form k clusters by assigning each point to the closest centroid. Recompute the centroid of each cluster until the centroids do not change. Yeah, that's the last step. So we are doing it until the clusters do not change. Okay, so that's how k-means clustering works. And there are key points in it: data in Euclidean space and document data. These are the two metrics which we'll be using to calculate k-means. So let's discuss what is that. Data in Euclidean space is a distance in which measures the quality of a clustering. Okay, that is sum of squared errors. So this is the formula, sum of squared errors. So we'll be taking each error, squaring it, and doing the sum. Okay, it's also known as scatter. SSE, it will be very much used in the upper means upcoming topics. So remember, there will be using just SSE. At that time you should remember I means sum of squared error. Okay, so this is one of the thing we'll be using, and the second thing we'll be using is the document data. So what is document data is, it is an objective in k-means to maximize the similarity of the documents in a cluster to cluster centroid. Okay, means how closely they are related, that is specified here. So what are the two metrics? The first one is the data in Euclidean space. We'll be using sum of squared error, and the second one is how closely they are related. For each of these there are two formula, you have to memorize this one. Okay, then we have two strategies to decrease SSE by increasing the clusters. What are those? Split a cluster and introduce a new cluster centroid. Okay, by using these two techniques, what we can do is that decrease the total SSE, means sum of squared errors should be very low, then it is a good algorithm. By increasing the number of clusters, if you increase the number of clusters, at that time this will decrease. How it will decrease? Based on two factors which are considering: split a cluster, means divide the cluster into smaller parts, or introduce a new cluster centroid. Okay, that will also divide into different parts. So when we divide the cluster into different parts, at that time there are total sum squared error will be decreased, because there are different groups and each of them will be close to one data point, right? So suppose that if I have a very big ground here, at that time I have So suppose that I have very big ground here. Okay, very big ground here, and one person is standing in middle of it. So he will be very far from the boundary. What if I divided the whole ground into different parts, smaller parts? At that time, what this person will be bound to the ground is that is also very close ground, right? He will be very close to the boundary. So that's what happens when you divide the bigger thing into smaller things. The individual data points will become closer to the centroid, and they will have less error values, but the number of clusters will increase. So that's what it is in the splitter cluster or introduce a new cluster centroid. Both will ensure that the data points are closer to the centroids. Next one is the tool strategy that decrease the number of clusters while trying to minimize SSE. To minimize SSE, it decreases also the number of clusters. That's very good, right? Less number of clusters as well as minimum size SSE. So disperse a cluster, merge two cluster. We can disperse a cluster or merge two cluster by using these two techniques. We can reduce the SSE while having the lower number of clusters. Okay. So that were the key points. The last key point is the bisecting k-means. Bisecting k-means means it means we can bisect it into different parts based on the same k-means algorithm. So when we bisect it, it will become half of the actual algorithm, and then it will become more sufficient. But that will take more means memory space, right? So we are just splitting it. Bisecting means splitting the k-means algorithm into different trails. So here we'll initialize the first list of clusters to contain the cluster consisting of all points. So the list of the clusters will be assigned, and then remove a cluster from the list of clusters, and from I to number of trails, bisect the selected cluster using basic k-means and end for. You have to do for all the clusters. You have to divide the cluster and see if it's making more efficient. At that time we will be continuing with it. Then we have selection of two clusters based on the bisection with the lowest total SSE. So that's how the algorithm of bisecting k-means works. Okay, and add this cluster to the list of clusters. After we have bisected and saw which one is more efficient, we'll be adding them. If the bisection was more sufficient or the original one was more efficient, we'll be adding that respectively to the original clusters until the list of clusters contains k clusters. We'll do this until k clusters are assigned. So don't stress more on it. Just make sure that we'll be the key point here is we'll have a cluster list of clusters. We'll take one cluster, we'll divide into two parts and see if it is more efficient. If it is more efficient, we'll add it to the list of clusters. If it's not, we'll not add. Okay, we'll do that until the total k clusters will be made. Okay, that's all what is happening here. We can go through it. Iteration 1, 2 and 3. So here see there are two clusters here, then we are dividing these clusters in different parts here and seeing if it's more efficient. If it is, then we'll continue with that, else we will divide the next also. Here two are divided, here these two are also divided. Okay, so that's what's happening in the bisection k clustering. Last topic of the k-means clustering, which is the strength and weakness and numerical. Then we'll be done with the k-means and we'll be left with two more agglomerative and DBSCAN, which are very simple ones. Then we'll be done with the half module. Okay, so let's quickly discuss what is the strength and weakness. Actually, you can go through it. I need not tell about these things, so you can go through it. And we'll be discussing the problem type now. So this is very important problem, so make sure you listen carefully. Consider the following data set k is equal to 2 3 4 10 11 12 20 25 and 30. So how many numbers are there? 1 2 3 4 5 6 7 8 9. Total 9 numbers are there, and what they will give is the number of clusters to be formed 2. So we have to just form 2 clusters, and the random mean value is m1 and m2 as 4 and 12. So 4 is one value and 12 is one value. What we are supposed to do is we have to assign to 4 all those numbers which are closer to 4, and assign to 12 what are numbers closer to 12. Suppose I got 10. Is 10 closer to 4 or 12? It is closer to 12, right? So I'll be assigning 10 to 12. What about 4? 4 is closer to 4 or 12? 4 is closer to 4, I'll assign it to 4. Like that we'll make two different groups. Okay, so that's what we are doing here. After we have made two groups, you'll have 2 3 4 here, and the remaining things 10 11 12 20 25 and 30, this will be present here. Okay, so the k1 is 2 3 4, and we'll be finding another mean of it. So a new mean will be formed after we have formed two groups. After seeing which numbers are closer to 4, these numbers are closer to 4, and the remaining numbers are closer to 12. When you calculate the new mean, it will come out as 2 plus 3 plus 4 divided by 3, which is 9 by 3, 3. Okay, and when we calculate the mean of this, we'll get as 18. Next, what we are supposed to do is we have to calculate all those numbers which are closer to 3 and place it in a cluster, and calculate all those numbers which are closer to 18 and place it in a cluster. For example, if I have 12, I'll be seeing if it is closer to 18 or closer to 3. At whatever answer I get, that I will be considering. Means if it is closer to 18, I'll keep it here. If it was closer to 3, I'll keep it here. Okay. And then again I'll calculate mean, I'll round it off, so it will be 5 and 20. Again I'll be doing the same thing, and then I'll get two new means, and again I'll be doing the same thing. After I get two means as same in the two iterations, at that time I'll stop. So these are the two clusters which I have. Okay, so that's how you'll be solving the k-means algorithm. Okay, which is a numerical associated with that. So we are done with the first topic, which is k-means algorithm. Okay, so I've discussed all the important parts. You can if you have missed any, you can means go to that part from where the k-means starts, and you can watch it again. Okay, so let's move on to the second part, which is agglomerative hierarchical clustering. Here we have the definition. So let's see what is the definition of agglomerative hierarchical clustering. Hierarchical clustering is a technique that are second important category of clustering methods. These approaches are old but still widely used. So there are two basic approaches for generating hierarchical clustering: agglomerative and divisive. Agglomerating means start with a point as an individual cluster, and at each step merge the closest pair of cluster. At each point merge the closest pair of cluster. Divisive is take a cluster and divide it into different parts. That is divisive. Okay. Hierarchical clustering is often displayed graphically using a tree like diagrams called dendrogram, which display both the clusters sub cluster relationship and order in which the clusters were merged or split. So here's the dendrogram result, and here is a nested cluster diagram. So p1, p2, p3, p4, those when they are subdivided, those means appear. Okay, and here it is appeared wherever it belongs to. Okay, so this is the innermost p2 and p3, so they are present here. This is the second tier, so it is present here. This is the first tier, so it is present here. Okay, a hierarchical clustering can also be graphically represented using a nested cluster diagram like this. Okay, let's see the next part, which is the key points. Hierarchical clustering, these two are we have already discussed. Defining the proximity between the clusters, min, max, and group average. Before that, we need to know the algorithm as well. So this is the algorithm. Compute the proximity matrix if necessary. We'll be seeing what is the proximity matrix and the different ways to calculate proximity matrix. Repeat. Merge the two closest clusters. Update the proximity matrix to reflect the proximity between new cluster and original cluster. What we are basically doing is we're computing the proximity matrix. That's the first step. We have the formulas for it, and then we are merging two closest clusters and update the proximity matrix again, and we are repeating it. Okay, so defining the proximity between the clusters, there are three ways: min, max, and group average. Min defines a cluster proximity as the proximity between the closest 2 points that are in different clusters and the shorter edge between the two nodes. Min means what is the minimum distance between these two. Max means what is the maximum distance between these 2 points. Group means we'll calculate all the distances from all the points to all the points, and then we'll be taking the average of it. That is the group average. These are the three ways to calculate the closeness of an object, which is means proximity means the distance between the clusters is calculated in three different ways, which we have discussed now, and the differences between them also is discussed. So those were the three different ways, and coming on to strength and weakness, you can read it. Okay, let's move on to the next one, which is the DBSCAN clustering. We have discussed the algorithm also for agglomerative hierarchical based. Let's move on to DBSCAN. Here also we have the definition, key points, algorithm, and strength and weakness. So what is the DBSCAN method? DBSCAN means density based scan. Okay, DBSCAN means density based scan. Density based clustering locates a region of high density that are separated from one another by region of low density. So there is a diagram here. There is low density at some point, part of the diagram, and some part has high density, so we'll be differentiating them between each other, and that is what DBSCAN does. So DBSCAN is a center based approach. That's our first point. First key point is it is a center based approach. So DBSCAN is a center based approach. There are several distinct methods, but DBSCAN is based on the center based approach. Center based approach means what? We'll be having a center here, and closeness to the center, how many points are there, that is known as the density. Okay, so that's what the density is, and the center base means we'll be having a center. Based on that, we'll be calculating how much dense it is. EPS means the different points, and EPS is the radius of that point to the center. Okay,
and classification of the points according to the center based approach. That's the second key point. First one is about the center based and classification of the center based approach. There are three kind of points: core points, border points, and noise points. Okay, noise points means background or outliers. So core points are points which lying in the core points are those which lie in the interior of the density based cluster. Border points are those which lie on the border or within the neighborhood of the core point. The last is the noise point, which lie in the outlier part, which is neither in the core nor in the neighbor part. So if I discuss here, A is the center and this is the points which are core points. This one, this one, this one, this one, this one. And the B point here, this lies in the neighborhood point. Okay, means it is a bit far. That is the border point, and this is the noise point which is not lying inside the border also, not lying in the core also. These are the noise points. Border points are these ones and core points are these ones which are closer to A. Okay, so that's what it is regarding the different kinds of points under the topic classification of points. Okay, according to center based approach. So started from here, what is DBSCAN? We saw it's density based clustering, and center based scan, it has center and EPS is the radius, and the number of points lying within the radius is used for calculation of density and classification of points according to center based approach. Core point, border point, noise points. Okay, so this is a diagram which you have to make and explain what is the differences between each of these. Just the key point difference is sufficient. Okay, then we have the algorithm for DBSCAN, and we are done with the second chapter. So what is the DBSCAN's algorithm? Label all the points as the core, border or noise. First you classify the points, then eliminate all the noise points. So we are just left with two, which is core and border. This is all we are concerned about. Okay, then put an edge between all the core points that are within the EPS and make each group of connected core points to separate cluster. So we have to make the groups now. After we have eliminated the noise points, we are left with core and border. We have to make a connection using an edge as EPS, which are within the EPS. Then we will be using that EPS value to make each group of connected core points. So one connected core point will be one group, another connected core point will be another group. Like that, we will make different groups for core. We are left with border. For border, assign each border point to one of the cluster to which it is closest to. You understood, right? First we are doing it for edge points, I mean the core points, we are forming the edge and connecting the points, and for border points we are connecting the cluster points, means for the which is closer to the core points. We have a border point to which point is closer the core point, we will be assigning the border point to the that point, core points cluster. Okay, that's the algorithm. Okay, then we have strength and weakness. You can go through it. Okay, so if you have not liked and subscribed my channel till now, please do it. It will help me make more videos like this. So let's move on to the next topic, which is cluster evaluation. So let's see what is in that. This is the third chapter, cluster evaluation. Mainly we have three things: unsupervised, supervised, and relative. Three types of cluster evaluation. So we'll first see what is cluster evaluation, and then we'll discuss three types and the subcategories under it. So let's see what is the meaning of cluster evaluation. Cluster evaluation means cluster validation. Means is the cluster good or not, that we are seeing. The evaluation of the resulting classification model is an integral part of the process developing classification model, and there are well separated measures and procedures. Accuracy and cross validation is an example for it, and will be classifying means will be validating the cluster based on some metrics. Okay, so cluster validity or the evaluation are traditionally classified into three following three types: unsupervised, supervised, and relative. Unsupervised, supervised, and relative. Okay, so what is in unsupervised, what is in supervised, what is in relative, what you need to keep in mind for these three from exam point of view we'll be discussing now. Okay, so let's see what are the topics under it. From unsupervised we have types. For supervised also we have types. For relative we just have the theory. Okay, so unsupervised we have three types: cohesion and separation and both. Cohesion, separation, and both. So let's see what is in cohesion, what is in separation, and what is in both. So what basically is unsupervised? Unsupervised means it will give the algorithm to find out the patterns. That's what unsupervised is. Okay, so we'll give some data points and tell to the computer that find out which is closer and find out which is dissimilar based on your criteria. So three criteria are there: cohesion, which means closeness of an object; separation, the differences between objects. Both will be using both cohesion and separation in Silhouette coefficient; and correlation. These are two ways which will be combining these both and using it for forming the clusters. Okay, so let's discuss The first one, which is the compactness and isolation. See, cluster cohesion and cluster separation. These are the two ways which we'll be using to means find out means make the clusters under the topic unsupervised. So what is cohesion? Cohesion means closeness. Separation means differences. So these are two formulas which you need to keep in mind and write in exam. Okay, it is based on similarity and dissimilarity. Cohesion means similarity. Separation means dissimilarity. Okay, we can calculate the overall validity also, how much closeness the things, how much close the objects were and how much far the objects were. Based on that, if we combine these both, we will get this answer here, means what is the different clusters formed, keeping in mind both the techniques. Okay, so for that, combining both, we use Silhouette coefficient and correlation matrix. So Silhouette coefficient is a popular method which combines both cohesion and separation. So here's an algorithm for it. It just calculates what is the separation and the cohesion by using a formula which is Silhouette coefficient. Si is equal to bi minus ai by max ai bi, and the values range from -1 to 1. The next one is the correlation. Here we'll have the confusion matrix. So we'll be seeing for each of these, what is the similarity between them, that will be marking here. If more similar means we'll be marking it more dotted way. If it's less similar, we'll be marking it a slightly lighter way. So why this is highly highlighted means it is the same thing. 1 and 1, what is the similarity between 1 and 1? Both are equal, so it will be maximum similar. So here we have dark, the diagonal element will be dark here. Okay, so that's the two ways in which what we'll do, two ways for which we'll be using both cohesion and separation for calculating the clusters. And the next ones were the individual ones, separation and cohesion, that's also I've discussed. So we are done with the first one, which is unsupervised. Let's see in supervised what is there. There are two types: classification oriented and similarity oriented. So let's see what is in the both of these topics. So supervised means we'll be providing labels. Supervised means we'll be providing labels. Okay. Classification oriented measures the number of measures such as entropy, purity, precision, recall, and F measure. These are the things which you need to keep in mind in writing exam. Okay, these are the factors which you'll consider for classification in classification oriented measures. Okay, so you can go through it. There are some formulas and it's very simple. You can also understand what it means. So I'm not going in depth of it. In similarity also we have few things like ideal cluster and ideal class. So that also it has the values 1 and 0. If it's more similar, it will be 1. If it's less similar, it will be 0. Then we have the last one, which is relative methods of cluster evaluation. It compares two different clusterings or cluster. A relative cluster evaluation is a supervised or unsupervised evaluation. It combines both the unsupervised as well as supervised. Okay, so that is relative, and relative measures are not actually a separate type of clustering evaluation measure, but instead a specific use of such measure. So we'll be specifically focusing on one based on context, and we'll be seeing which are the benefits of both of these, and that we'll be using. That is a relative method of cluster evaluation. Okay, so for example, two k-means clustering can be compared using either SSE or entropy. So we are just using this as a comparison tool to compare the two different clustering algorithms. Okay, so that comes under that covers up the topic cluster evaluation or cluster validation. Moving on to the last chapter, we have three topics: density based, graph based, and scalable. Let's see what is the important things in this and what you need to keep in mind. So the first one is the density based clustering. Density based clustering classifies based on the density. It's obvious from the name itself, right? So the most widely used is DBSCAN, we have already discussed. The remaining three are grid based, clique, and DENCLU. Grid based is based on the grid and the cell values. The more closer it is, the more dense it is, the darker the grid value will be. Okay, so here's the algorithm, you can go through it. Next we have the also have the strength and weakness, that also you can read. Clique is the clustering in queue. We'll be using a queue in a grid based algorithm which will find the subspace clusters, which will form the sub clusters from the main cluster. Okay, so here's also the algorithm and the strength and limitation. Why I'm not focusing much is because from these three topics much questions are not asked. Okay, so I'm trying to focus more on what is important. Okay, so you can easily read this, just have a slight information of what it is. Okay, then we have the DENCLU, which is density clustering. It is a kernel based scheme for density based clustering that models the overall density based on a function. So function is the main thing that you need to keep in mind. Function makes the peak and the bottom parts. Okay, based on this we'll be calculating density and we'll be setting the threshold values. So which form less than the threshold we will not consider, which form more than threshold, that only will be considering. Okay, so those were the three topics: grid, clique and then queue. In grid we will form the grids and the cells darker color represents more dense, and clique means we will be forming the queues of the clusters, and there will be doing. Then we will be using the denq, which is nothing but just now we discussed about these things. We'll be forming the density functions. By using the peak values, we'll be setting the threshold. Which is less than threshold, we'll not consider. Which is more than threshold, we'll consider that. Then we have graph based and scalable. In graph based, we have 5, which is MST, Opossum, Chameleon, Jarvis, and SNN. So let's see what is there in each of these. In graph based, we'll be classifying by using the graph properties of the algorithm. Okay, so sparsify the proximity graph to keep only the connections of all the objects. So we are just using the sparse matrix to calculate which points are closer and which points are not closer by using the graphical method. Okay, sparsification means we'll be having the values which are more closer and which are far closer. Okay, so this is how it works. Data set is here. We'll be forming a proximity matrix, and then we'll be representing this matrix in the form of graph, and then we'll be dividing it into different clusters. Okay, so that different techniques. MST, minimum spanning tree, means if you have a tree, in which way if we travel in the tree we'll get minimum cost, that is minimum spanning tree. Opossum, Chameleon, Jarvis Patrick clustering, SNN density based clustering. So MST is this one only. This already discussed, and the algorithm also given here. Optimal partitioning of sparse similarity using METIS. So METIS is a technique which we'll be using to form the different partitions, and we'll be using sparse matrix here. Chameleon is a hierarchical clustering with the dynamic modeling. We'll be using the dynamic modeling to form the clusters. Okay, so first we'll be forming the sparse graph clusters here, partition it, again merge them into which is closer. So this will be the final cluster in Chameleon algorithm. Then we have the Jarvis-Patrick clustering algorithm. Here we have the threshold used to sparsify the matrix of SNN similarities. Okay, so this is how the original data looks like, and the clusters by JP algorithm, it will look like this. Okay, so here also some things are there, like very common thing, very slight differences. So don't pay much attention to it because this is very less repeated topic. So just know what it is, that's sufficient. Okay, and know this diagram as well. Then what we have is the SNN density based. This is also density based. SNN is a factor which will be considering in the particular algorithm. Okay, that's all. What is the difference? Moving on to the last topic, which is scalable algorithms. Some issues, birch, cure. So these two topics. So scalable algorithm, don't ignore. Among these three, this is the most important. Scalable algorithm. There are some issues which we'll be discussing. Yeah. And then we have two algorithms, birch and cure. So let's see what is the means issues with respect to this. So clustering techniques face significant problems on scalability for a very large of data sets that are becoming increasingly common. The general strategy to increase the scalability are reducing the number of proximity calculations. Means if you reduce means the proximity calculation, the larger area will be captured, right? Because we are not considering the closeness. Sampling the data into different parts, partitioning the data, clustering a summarized representation. Okay, so two examples for scalable clustering algorithm are Cura and Birch. So we'll be discussing this later. Some general issues are as follows, like the amount of storage required will be more, and there are a variety of techniques for reducing the amount of computation storage required, multidimensional, bound on proximities, sampling, partitioning, and summarization, parallel and distributed computation. So you can go through this to get more information regarding this, but now you got the brief overview, right? What are the issues, right? Next we have the Birch and Cure. Birch is balanced iterative reducing and clustering using hierarchical. Okay, so we'll be using the vector space and the means the distances between the points to calculate which is the best algorithm, means best clusters. Okay, so we'll be doing some things like linear search and all. You can go through it and you'll get more information regarding this. Then we have the Cure, which is the clustering using representatives. Okay, in representatives we'll be using some key points which will be non-spherical shapes and non-uniform sizes. Based on that we will be handling the large data sets and creating the clusters. Okay, so it will look like this. Initial sample will be like this, then we will create the clusters based on the shape and size, and then we will be forming the better clusters. Okay, so that's all what is there in the fifth module, and thank you so much for watching. I'll see you in the next one.